A space shuttle drifts away from a newly deployed telescope. Below it, Earth fills the frame in white clouds and blue oceans. The telescope hangs above the atmosphere, unfolding into the environment it was built for. For years, this moment had represented the destination. The difficult part seemed finished. The telescope was called Hubble. It had been built to become the clearest eye ever turned toward the universe. No weather, no atmosphere, no shimmering air between the mirror and the stars. The launch had worked. The deployment had worked. Now there was only one question left. What would it see? The first signals arrived from orbit. Electronics responded. Instruments powered on. Images began flowing back to Earth. The telescope had opened its eye. And then something strange appeared. A star should have looked like a sharp point of light. Instead, it looked soft. Light spread outward where it should have concentrated inward. Bright objects seemed surrounded by a faint haze. The telescope was seeing, but it was not seeing clearly. At first, that did not seem alarming. The observatory was new. Complex instruments often required adjustment after reaching space. Focus settings could be refined. Calibration procedures could take time. A newly deployed machine was rarely perfect on its first attempt. The explanation felt reasonable because everything else appeared healthy. Commands traveled upward. Data traveled downward. The telescope obeyed instructions. The eye was open. Perhaps it simply needed glasses. Days passed. Engineers adjusted settings. New images arrived. The blur remained. Another set of observations followed. The blur remained. Nothing looked obviously broken. That made the problem harder to understand. If the telescope were dead, the diagnosis would be simple. Instead, it was functioning. Every new image confirmed that. Every new image also confirmed something was wrong. Attention settled on the most convenient suspects. Maybe a camera was malfunctioning. Maybe a detector had shifted during launch. Maybe a focusing mechanism was slightly out of position. The explanation fit the evidence. A camera problem could easily produce disappointing images. The search narrowed toward individual instruments. Then another camera was tested. The expectation was simple. If one camera was causing the distortion, a different camera should produce a different result. The images arrived. They looked disturbingly familiar. The blur was still there. Different hardware, same distortion. The observation did not immediately destroy the existing explanation, but it weakened it. A little confidence disappeared. Another test followed. Again, the telescope produced images. The same strange signature appeared. Light that should have converged into a sharp point seemed to spread outward into a small, glowing cloud. The pattern kept repeating. The cameras were different. The flaw was not. That created a new question. What did all of these instruments have in common? Every camera, detector, and imaging system depended on the same optical path. The light entered through the same opening. Reflected from the same primary mirror, traveled through the same telescope. The possibility was uncomfortable because it pointed toward the one component nobody wanted to suspect. Because if that component was wrong, there was no backup waiting on Earth. No software update. No replacement launch. The mirror. Everything about Hubble depended on that surface. It was the foundation beneath every observation. If the mirror was correct, the telescope could succeed.
The blurring
If the mirror was wrong, every instrument inherited the mistake. The investigation began shifting away from cameras and toward optics. Not because anyone wanted that answer, because the evidence kept removing alternatives. The telescope was already hundreds of miles above Earth. No one could walk up to it. No one could touch the mirror. No one could simply inspect the surface with their own eyes. The only clues arrived as patterns in light. Images became evidence. Distortions became measurements. The blur itself became a map. Gradually, a picture emerged. The mirror had the wrong shape. Not dramatically wrong. Not visibly wrong to a casual observer. Wrong by an amount so small that it seemed almost impossible for such consequences to follow. The flaw was microscopic. The consequences were not. Yet telescopes live and die by precision. The primary mirror had been polished into a curve that differed from the intended design. Light entering the telescope reflected exactly as the mirror instructed. The problem was that the mirror had been giving the wrong instructions all along. Suddenly, the entire story changed meaning. The launch had succeeded. The deployment had succeeded. The electronics had succeeded. The cameras had succeeded.
Discovery, you are aligned
The
for
telescope
final
had
approach. Capture
faithfully
velocity is
performed
good.
its task.
Roger that, Houston. Grapple
It had
fixture
simply been built
engaged
around
to
an
wheel
optical
self-capture.
flaw hidden deep within its foundation. The blurry images were not evidence of a failing mission. They were evidence of a mission discovering its own hidden defect. The contradiction became painfully clear. The better Hubble functioned, the more obvious the flaw became. Success was exposing failure. Diagrams of the optical system transformed an invisible problem into something people could finally see.
Final checks initiated.
Light rays that should have converged into a single point missed their target. Instead of meeting neatly, they spread apart. Every fuzzy star image traced back to the same source. The mirror. That realization created a new pressure. The telescope was already in orbit. Replacing the mirror was not an option. The flaw existed inside the one component every observation depended upon. A telescope built to see clearly had carried its mistake into space. Yet the story did not end there. Engineers began exploring a different possibility. If the mirror could not be replaced, perhaps its error could be counteracted. The solution resembled a familiar idea. Glasses do not repair an eye. They compensate for it. Corrective optics could do something similar for Hubble. The idea sounded almost absurd. If the mirror could not be fixed, engineers would build optics designed specifically to compensate for its mistake. Additional optical components were designed to intercept the distorted light and redirect it before it reached the instruments. Instead of removing the flaw, they would cancel its effects. The telescope would not become perfect. It would become corrected. Years after that first disappointment, new hardware reached the observatory. The corrective optics were installed. Then the images returned. This time, the stars looked different. Sharp. Precise. Exactly as they should have appeared from the beginning. Details emerged. The haze disappeared. The eye that had opened and seen blur finally saw clearly. And that changes the meaning of the beginning. When Hubble separated from the shuttle and floated above Earth, it looked like a completed triumph. In reality, that moment was not the end of the story. It was the moment the story became visible. The telescope opened its eye, and the blur revealed a flaw that had survived design, manufacturing, testing, launch, and deployment. Only when Hubble finally began doing its job did the hidden error step into the light. The launch succeeded. The mirror did not. Hubble spent the years that followed proving the difference.